I found this article in National Geographic. The title is Antibiotic Found in Noses. Here's what you need to know. The article is written by Michael Greshko, and the subtitle is An antibiotic effective against drug-resistant staph infections comes from an unlikely source, bacteria inside the human nose. On Wednesday, a team of German microbiologists unveiled a new kind of antibiotic from an unlikely source, bacteria that call the human body home. Got questions about how they sniffed out the discovery? Here's everything you need to know. In a nutshell, what did the researchers find? The team found a first-of-its-kind antibiotic called Lugdunin that's extremely effective against the bacterium Staphylococcus aureus, which can be resistant to many common antibiotics and cause serious infections. For instance, Staphylococcus aureus is the species behind the notorious MRSA infections. And, as the team points out in Nature, the drug maker is all natural. A bacterium called staphlococcus-lugdunensis secretes the antibiotic. That sounds like a useful species. Where did they find it? Here's the cool part. Staphylococcus-lugdunensis lives in the human nose. Why were researchers looking for antibiotics in their noses? Well, technically, they weren't looking in their noses. They were looking through massive libraries of bacterial cultures that they had collected from other people's noses. Previous work has identified promising antibiotics within the human microbiome, so the researchers were looking for more by seeing if some bacterial cultures inhibited the growth of others. It's the same basic method that Alexander Fleming accidentally used to discover penicillin in 1928. Wait, what's the microbiome? Your body is an ecosystem unto itself, home to a bewilderingly vast array of microorganisms that co-evolved with us and, depending on when you had your last bowel movement, may or may not outnumber your body's cells. Microorganisms living in and on your body play important roles in regulating immune responses, aiding digestion, and crowding out nefarious pathogens. For instance, human breast milk contains sugars that specifically nourish the bacterium that populates babies' guts, a strategy that defends babies' intestines against pathogenic viruses and bacteria. So is this nasal bacterium producing the antibiotic to help us? Strictly speaking, no. It turns out that the bacterium naturally wields the antibiotic to defend its turf against invading hordes of Staphylococcus aureus. Even when outnumbered 10-1 in a petri dish, Staphlococcus-lugdunensis managed to kill off encroaching Staph aureus, an upset that researchers confirmed by inoculating the noses of lab rats with mixtures of the two bacteria. However, a strain of Staph lugdunensis with a broken Lugdunin gene couldn't pull off the comeback, strongly suggesting that Lugdunin was its weapon of choice against Staph aureus. Is Lugdunin the first antibiotic discovered in the human microbiome? No, but it's special nonetheless. In the last few years, we've learned that bacteria in the human microbiome can produce powerful compounds that have good and bad effects on people. Bacteria in the vaginal cavity, for instance, secrete an antibiotic called lactocillin, while some gut bacteria make a DNA-damaging toxin called colibactin that seems to increase the risk of colorectal cancer. But all told, these sorts of secreted compounds, called secondary metabolites, are rare within the human microbiome, and it's even more uncommon to learn how and why bacteria use them, as researchers did with Lugdunin. By contrast, scientists are still trying to pin down how bacteria use lactocillin in the vaginal ecosystem, and they're not even entirely sure how the penicillin mold uses penicillin in the wild. So how does the new antibiotic work? Lugdunin's discoverers don't know for sure, but after Staph aureus is exposed to Lugdunin, it stops taking in all sorts of vital building blocks, suggesting that the compound somehow breaks the bacterium's overall metabolism, mirroring the general effects of the antibiotic daptomycin. Antibiotics generally work in one of a few ways. Some ravage bacteria's cell membranes or their outer cell walls, while others gum up their protein-making machinery or prevent bacteria from repairing their DNA. Surprisingly, researchers often struggle to nail down precisely how individual ones work, even once they're successfully commercialized. Daptomycin was discovered in the late 1980s, but scientists still aren't totally sure how it does the job. Well, no matter what, A new antibiotic sounds great. When will humans start using it? Not so fast. It'll be years before human clinical trials begin, and even then there's no guarantee that Lugdunin will be deemed safe and effective. Daptomycin, for instance, took more than a decade to obtain approval from the U.S. Food and Drug Administration, getting the formal sign-off in September 2003. But as it stands, plenty of people probably have reaped the advantages of the antibiotic without even knowing it. The researchers checked the nasal microbiomes of 187 hospital patients, and only one of the 17 patients with staphlococcus-lugdunensis colonies also carried Staph aureus. By contrast, nearly two-thirds of the people without staphlococcus-lugdunensis carried Staph aureus, and sure enough, all of the hospital patients' staphlococcus-lugdunensis colonies produced Lugdunin. In other words, a helpful bacterium was hiding under our noses the whole time, by hiding in them.